Anyone? Nothing? Okay.
I had a question about number 40 for 1.3.
Can you give it to
So
me?
I
I don't
get
have it.
how
I didn't write solutions yet.
I'm sorry, can you repeat it? I couldn't hear you.
Yes. Should I reboot my system? I do not come across clear enough. Do you want me to reboot my system?
No, I think it just went out for a second, but I can hear you clearly.
Okay, but if at any point in time you think that I should reboot my system, I'll do it and it will take a blink. Okay, so I should look for this problem.
It's page 125.
Page
Do you want me to put
120.
it in the chat or yeah?
You said it's page 125. Problem 40. Okay.
Yeah.
So at the beginning of the trip, so time t, this is always time independent. The odometer says 30,680. And it has full tank. Okay. At the end of the trip, the odometer, okay, at the end of the trip, I don't know, it reads 31,077. If the time is what I want, I don't know, maybe it's the amount of gas. I didn't read the problem. So I'm continuing and I make adjustments as we go along. It takes 13.5 gallons of gas to refill the tank. Okay, so initially it was 13.5, comma 30680. And then I'm assuming that at the end of the trip, okay, it doesn't say the beginning of the trip, the odometer, okay, and the car, okay. At the end of the trip, the odometer reads this. It takes, okay, to refill the tank. So I'm assuming this is 0 for now. What is the average rate at which the car was traveling in miles per gallon? Okay, so the average rate, y2 minus y1 over x2 minus x1. So 31077 minus 30680 divided by 0 minus, so negative 13.5. The measurement unit, again, is the average rate of change at which the car was traveling in miles per gallon. So the measurement unit, whatever I get, it has to be miles per gallon. Okay, I have my calculator right here. So I divide 31077, 30680. Lazy people use a calculator for a difference, and that's what I'm doing, and divide by 13.5. So it's negative 29.41. Now it depends if they said anything about how to present the answer. So what is the average rate? So this minus this over this minus this. So negative 29.41 miles per gallon. Since I can't have a negative, I can't say, you can, actually, it is correct. The negative is correct. The negative does not say that it's negative 29.41. It says it's decreasing. All rates that are decreasing are negative. All rates that are increasing are positive. So please remember that. Okay, in part B, what is the average rate of gas consumption in gallons per mile? So now the average rate of gas consumption in gallons per mile. So what they want now, they want us to reverse. They want us to use this as the y variable and this as the x variable. So something like 30, 30,680, 13.5, and 31,077, 0. So now they want the average rate to be 0 minus 13.5 over 31,077 minus 30,680. And this time it's going to be gallon per mile, measurement unit. So 13.5 divided by, in parentheses, don't forget parentheses, 0.77 Okay, so I got still negative. You can report it positive, but this means decreasing. So 0.034. Again, I don't know how many decimal digits they want, but I'm fine with 2 or 3, I'm fine. Very good question. Is this okay?
Yes, thank you.
Very good. My pleasure. Anything else? Other questions? Other questions?
I do have a question.
Yes, I'm ready. I'm ready. Yes.
In section 1.2, number 36, it's not entirely specific to the question, but rather when it asks, because the question is when the limit is x approaches 3 from the right, and it's equal to the square root of x squared minus 9.
You mean from?
Hold on. Yeah, the square root of x squared minus 9.
And x approaches 3?
Mm-hmm.
From the right?
My question is, why is it necessary to have it coming from the right?
That's what they're asking. I cannot change the problem.
Okay.
Okay. Have you looked at this?
Mm-hmm.
Yes?
Mm-hmm.
So you know that the domain of this function is negative infinity to negative 3 and 3 to infinity, right?
Yeah.
Okay, so x squared minus 9 must be greater or equal to 0 implies that the domain of this function is negative infinity, negative 3, union 3 to infinity. So 3 from the right is here. The function is defined. When you plug in, you get 0, and the limit is 0.
Okay.
Now, if the same is asking for the limit as x approaches 3 from the left, you have to say DNE. Because 3 from the left, right here, the function does not exist.
Okay.
But this analysis is part of the problem. Just writing 0 will not bring too much credit.
Mm-hmm.
So the domain has to be determined first, and then you can analyze. The same thing if I have x approaches negative 3 from the left, I will get 0 because it's right here. The function exists. But if I have x approaches negative 3 from the right, I will say DNE because this will be right here where the function does not exist.
Okay.
So that's why the analysis of the domain is absolutely mandatory. And that's why I showed it to you here. You don't have, you can use, because it's quadratic, you can use the graph, but this is more elegant way, but it's up to you. But the domain has to be determined first. Is this okay? Perfect. I think I can recycle that one now. Good, perfect questions. Anything else? Anything else from anything else? Okay then, so we established last time in 1.4, which I did not mention it was 1.4. So that's why I kept this. We established slowly but surely that when we want to determine the rate of change of this function at this point, we start first with the secant line and we approach Q. Q will get closer and closer to P, which means as approaches 0. So through this step-by-step analogy, we realize that the limit of the difference quotient is the slope of the tangent line at P. And this concept, putting together the limit and the difference quotient for a function f of x, gives us something called the derivative function. So before I recycle this, I'm going to write what we wrote last time. So f prime of x is the limit as age approaches 0 from f of x plus age minus f of x divided by age. We're going to look at some very important functions, but before that, I would like to discuss one important topic. When a function does not have a derivative, in which situations f prime does not exist, or f prime does not exist, or, and this is very important to remember, f of x. So you either say when a function does not have a derivative, or f prime of x does not exist, or, and this is the most important one, I accept any of these three. But this is an important concept to remember. Or f of x is not differentiable. All these three mean the same thing. When a function does not have a derivative, or we say f prime does not exist, or we say f of x is not differentiable. I accept any of these, but I need you to know this word in case you hear it or you see it somewhere and you know what it means now. Okay, here are the situations in which a function will not have a derivative or will not be differentiable. Here's one. So back to, I just put it in my recycling bin. I have to take it out. Back to this for a second. This is this function evaluated at this point. The slope of this line is this function evaluated at this point. The slope right here of this tangent is this function evaluated for this x, and so on and so forth. At every point, if I find more than one tangent, or if the tangent is vertical, this function does not exist. The derivative will not exist. So here are the examples. Look at this point when x is a. I have a tangent here and a tangent here. Two tangents. So this is not continuous. If it's not continuous, the derivative at this point does not exist. The function is not differentiable at a because it's not continuous. Okay, here's another example. If it's not continuous, it cannot be differentiable at that point. It's differentiable everywhere here. It's differentiable everywhere here, but not at this point. Okay, here's another example. This is called the corner. How come? Because it has two tangents at this point. One going this way, having a positive slope, and one going this way, having a negative slope. Not differentiable. Not differentiable for not being continuous. Not differentiable for having a corner. And here's another. Pretty similar. These two are pretty similar. Here's one, like between two teeth. It's called the cusp. And here's another situation, and as I said, they are very similar, these two. It's a vertical tangent. Only at this point is not differentiable. Only at this point is not differentiable. It's differentiable everywhere else. So this is called a vertical tangent. So we will be able to find the rate of change of this function anywhere else except here, anywhere else except here, anywhere else except at this corner, anywhere else except at A. Okay, now I would like us to look at some functions and determine their derivative using the definition of the derivative. I will give you a list. I would like to look at this. I would like to look at this. And that's enough for now. I wanted to add exponential, but we have a special chapter that deals with this, chapter 3. So we don't have to do the exponential right now. Okay, so let's choose either one. And